Say you type one sentence to an AI agent. Book me a flight to Chicago next Thursday, economy. Keep it under $400. Use my visa. 6 seconds of typing. And somewhere behind that sentence, a piece of software is about to go find a flight, hand over a card number, and spend real money on its own without you watching it happen. Here's the question that should stop you for a second. What actually happens between you hitting enter and the charge landing on your card? Because the AI booked it is not an answer. Something has to happen in between. Something has to decide this is the right flight, the right price, the right card before any money moves. And here's the part almost nobody explains clearly, that something is usually not the same system that made the booking decision in the first place. It's a second system, a checker. And understanding exactly what that checker does and exactly what it cannot do is the difference between trusting these agents with your money and getting burned by them in a way you never saw coming. So here's what we're going to do. We're going to follow this exact flight booking, start to finish, through every step of the pipeline. Agent reads your request. Agent picks a flight. And then, before a single dollar moves, a second gate opens up. A checkpoint that either lets the booking through or slams it shut and kicks it back. We'll watch that gate catch the obvious mistakes, the wrong destination, the wrong price, the wrong card, business class when you said economy, all of it caught every time like clockwork. Then we're going to do the more interesting thing. We're going to break the checkpoint. Not by imagining some far-off sci-fi failure, by showing you two very specific, very real ways this exact gate on this exact flight booking can wave through something that is completely wrong and never even notice. One of them is about what correct even means. The other is about who's doing the checking. And once you see both of those, you will never look at we added a safety check the same way again. For AI agents, or honestly for any system that acts on your behalf. Quick honest note before we go further, because this touches money and technology decisions some of you might actually be making. Nothing here is financial or technical advice for your specific situation, and the field of AI agent safety is moving fast enough that some specifics will be outdated within a year or two. What won't be outdated is the way of thinking. That's what we're really building today. One flight, one gate, two kinds of failure. Let's go step by step. Here's why this isn't an abstract engineering topic. Right now, companies are racing to hand AI agents actual authority. Book this, buy that, transfer this, cancel that. Because doing it by hand is slow, and doing it through an agent is fast. Airlines, expense platforms, shopping assistants, corporate procurement tools. The pitch is simple. Tell it what you want, it handles the rest. But handles the rest means it's making decisions with your money, your calendar, your commitments, while you're not looking. If it books the wrong flight, that's not a typo you catch and fix. That's you standing in the wrong airport on the wrong day. Or a business class charge on a trip you were told would stay under budget. Multiply that by a company running thousands of these bookings a month instead of one person doing it themselves. And a small failure rate stops being a curiosity and starts being a real cost. This is why the checkpoint exists at all. And it's exactly why it matters whether the checkpoint is actually doing its job or just making everyone feel safer while doing less than they think. To understand why this checkpoint had to be invented, it helps to see where AI agents came from. For a long time, AI mostly meant something that answered questions. You typed something in, it typed something back, and nothing in the real world moved. No money changed hands. No calendar event got created. It was a conversation, not an action. That changed once these systems got connected to tools. The ability to actually call a booking website, submit a payment, send an email, edit a file. The moment an AI system could do something instead of just say something, a new problem showed up that had never really mattered before. What if it does the wrong thing confidently, and nobody's there to catch it before it happens? Early agent builders ran into this almost immediately. An agent told to clean up my inbox would delete something important. An agent told to find the cheapest option would pick something that technically matched the words, but obviously violated what the person actually meant. The failures weren't exotic. They were mundane, almost boring. And that was the disturbing part. A system could sound completely confident and still be completely wrong. And there was no built-in moment where anyone, human or machine, stopped to double-check before the action went through. So the industry landed on an old idea, borrowed from much older engineering. Don't just trust the one system that made the decision. Put a second independent check in front of anything expensive or irreversible. Banks have done this for decades with fraud review. Aviation has done it for decades with dual pilot procedures and separate safety checks that don't report to the same person. The insight carried over almost exactly. Before an AI agent's action becomes real, a second system, a stricter, narrower, less persuadable one, gets a look first. That second system is what we're calling the checkpoint. And the road that got us here, from AI that talks to AI that acts, but only after something else says yes, is the road this whole video sits on top of. Let's put it back on our one flight. You told the agent, Chicago next Thursday, economy under $400, your visa. Watch what happens in order. Step 1. The agent parses your intent. It's turning your sentence into something structured. Destination Chicago, date next Thursday, cabin economy, budget cap 400, payment method that specific visa. Think of it like translating your sentence into a form with blank fields, and the agent is the one filling in those fields based on what it thinks you meant. Step 2. The agent goes and does the work. It searches flights, compares a few options, and lands on one, say a Thursday afternoon flight, economy, $340, charged to your visa. It now has a proposed action. Not a booked action, a proposed one. This is the crucial hinge point of everything we're talking about today. The agent does not get to go straight from "I've decided" to "money moves." There's a stop sign in between. Step 3, that proposed action gets handed to the checkpoint. And this is the part almost nobody outside the field ever sees. The checkpoint is not the same brain that picked the flight. Sometimes it's a second AI model given a narrow, almost adversarial job. Don't be helpful. Don't be creative. Just compare this proposed action against a strict specification and look for a reason to say no. Sometimes it's not AI at all. It's hard-coded rules, plain old programming logic, checking a handful of yes or no boxes. A lot of real systems use both together, rules for the things that are black and white, a second model for the things that need a little more judgment. Picture our recurring diagram right now. A box labeled agent, an arrow to a box labeled proposed action, an arrow into a box labeled verifier checkpoint, and that box splits into two paths. Pass, which continues on to execute, and fail, which loops back to block. And from there, either back to the agent to try again, or up to a human. For our flight, the checkpoint pulls out the same fields the agent filled in and asks a short list of blunt questions. Is the destination Chicago matching what the user actually typed? Is the date next Thursday? Is the cabin economy, not business? Is the price $340, which is less than or equal to $400? Is the payment method the specific Visa the user named, not some other card sitting on file? Every one of those is a yes. The checkpoint passes it. The booking executes, money moves, ticket issues, and the whole thing took a fraction of a second longer than if there'd been no checkpoint at all. Now flip one detail. Say the agent, trying to be helpful, decided the economy seats were sold out and quietly upgraded to business class for $80 more, thinking that's obviously what you'd want. Same pipeline, same checkpoint, same question. Is the cabin economy? No. It's business. That's a flat mismatch against the stated policy. Fail, blocked, kicked back before a cent moves. That single failed checkbox is the entire point of this video in miniature. A specific, boring, mechanical mismatch caught by a specific, boring, mechanical check before it became your problem. Here's where it's worth being precise, because two words get used almost interchangeably in casual conversation about this, and they mean genuinely different things. Verification is checking a proposed action against a spec. It's asking, does this match the rules I was given? Right cabin, right price ceiling, right recipient, right payment method, right format. Verification never asks whether the rules themselves are correct or whether the user's real intent got captured accurately upstream. It just checks the action against the paperwork. Validation is a different, harder question. Does the outcome match what the user actually truly wanted? Not what the request said, what the person meant. A booking can pass verification perfectly. Right price, right cabin, right card, and still fail validation because the destination was subtly wrong for reasons the checkpoint had no way to see. Verification checks the map. Validation checks whether the map matches the territory. That distinction is going to matter enormously in a few minutes, so hold on to it. Verification against a spec, validation against true intent. With that distinction in hand, here's the taxonomy. The actual list of things a spec-based checkpoint structurally can catch, because they show up as a clean mismatch against a rule. Wrong amount, the price exceeds the stated budget. Wrong recipient or destination. Chicago requested, Denver proposed. Wrong dates, Thursday requested, Friday proposed. Malformed requests. A field is missing or garbled, like a payment method that doesn't parse as a valid card. Policy violations. Business class booked when policy says economy, exactly like we just saw. Out of bounds actions. The agent tries to book a rental car when it was only asked to book a flight. And schema mismatches. The proposed action doesn't even have the shape the checkpoint expects, so it gets rejected on structure alone before it's even evaluated on content. Let's prove this generalizes past travel with a second, quicker example. Same architecture, different agent. A purchasing agent told to buy a specific part from a specific supplier, capped at $200. It proposes a purchase for that part from that supplier at $180. Checkpoint compares supplier name, part number, and price against the spec. All match, passes, executes. Now the agent proposes the same part, but from an unapproved third-party seller at the same price. Supplier field doesn't match the approved list. Fail, blocked. Same shape of gate, same shape of catch, totally different domain. That's the pattern. Wherever you can write down a spec, a budget, a recipient, a policy, you can build a checkpoint that reliably enforces it. And notice something about every single item on that taxonomy. They're all boring. They're all mechanical. They're all things you could check with a checklist and a calculator. That's not a criticism. Boring and mechanical is exactly what you want a safety layer to be. Because boring things are reliable, and reliable is the whole point. But it's also exactly why this list has a limit. A checklist can only ever catch things that show up as a checklist violation. So here's the pivot. And it's the part of this that almost nobody walks through clearly. There are two specific ways this exact checkpoint on this exact flight booking can pass something that is completely wrong. And neither one shows up as a checklist violation, which means neither one gets caught. The first is subtle intent manipulation. Remember the distinction from a minute ago. Verification checks the action against a spec, not against the user's true intent. So what happens if the spec itself was quietly corrupted before the checkpoint ever saw it? Picture this. Somewhere upstream, the agent read a web page or an email or some piece of context to help plan your trip. And buried in that content was an instruction it wasn't supposed to treat as a command, but did anyway. A prompt injection. That hidden instruction nudges the agent's understanding of your intent just slightly. Maybe it decides the real destination should be a connecting city that happens to route through an airport where the attacker benefits, or it decides your intent secretly included adding a companion fare to a second account. The agent now genuinely believes, incorrectly, that this is what you asked for. It fills out the proposed action to match that corrupted belief. Destination field matches. Price matches. Cabin matches. Every box the checkpoint knows how to check comes back clean, because the checkpoint is only ever comparing the action to the agent's stated intent. And the stated intent itself was the thing that got poisoned. The checkpoint did its job perfectly and still let something wrong straight through, because it was never built to ask, is this spec itself the right spec? That's verification succeeding while validation silently fails, and it's invisible from inside the checkpoint's own logic. The second failure mode is even more structural, and it's called correlated failure. Here's the setup. The whole reason a checkpoint works is that it's independent of the agent. A second different judgment catching what the first one missed. But in practice, independent gets faked more often than you'd think. If the checkpoint is a second AI model built by the same vendor, trained on similar data, descended from the same base model family as the agent it's supposed to be checking, then the two systems don't have two different blind spots. They have the same blind spot, twice. Whatever edge case confuses the agent into making a bad decision is very likely to confuse the checkpoint into approving that same bad decision for the exact same underlying reason. It's not two guards checking each other's work. It's one guard's reflection in a mirror, agreeing with itself. Even a rules-based checkpoint isn't automatically safe from this. If the rules were written by the same team, using the same assumptions about what normal bookings look like as the team that built the agent, an edge case nobody on that team anticipated slips past both, because both were shaped by the same blind spot from the start. Put those two together and you get the honest, complete picture. Independence isn't a box you check by having two systems instead of one. It's a property that has to be engineered on purpose. Different vendors, different underlying models, different teams writing the assumptions, ideally different training data entirely. Anything less is theater that happens to look like safety. This is exactly why, right now, you're hearing real hesitation from serious money about handing AI agents true autonomy. There's been open, public skepticism from parts of Wall Street about turning AI agents loose on financial decisions at scale. Hundreds of billions of dollars of potential exposure being treated with genuine caution, not because agents can't work, but because the industry knows these two failure modes are real and still mostly unsolved. That hesitation isn't fear of the technology. It's a completely rational response to knowing that a checkpoint can pass an audit and still be blind to the exact failure that matters most. So where does that leave us, honestly? The checkpoint is real, it works, and you should absolutely want one in front of any AI agent that spends money or takes irreversible action on your behalf. It reliably catches wrong amounts, wrong destinations, wrong dates, wrong payment methods, policy violations, malformed requests, and out-of-bounds actions. The entire boring mechanical taxonomy we walked through. That's not a small win. That's most of the failures, most of the time, caught before they cost you anything. What's proven is that spec-based checkpoints measurably reduce the boring failure category. What's not settled, and may never be fully settled, is how to reliably catch the other two. Intent manipulation upstream of the checkpoint and correlated blindness between the checker and the checked. Nobody credible claims those are solved. The honest field-wide answer right now is that they require structurally different tools than a checkpoint. Things like diverse model ensembles, where the second check genuinely comes from a different lineage than the first. Human review thresholds, where anything above a certain dollar amount or a certain irreversibility gets a real person's eyes before it executes. An out-of-band confirmation, where the system asks you to confirm the actual details through a separate channel it can't have quietly corrupted, like a text to your phone that states the flight, the price, and the card in plain language. So here's the mental model to actually carry with you. A verification checkpoint is necessary, but it is never sufficient. It takes a wide, messy space of everything that could go wrong and shrinks it down to two piles. One pile is boring and catchable. Wrong price, wrong destination, wrong policy. And the checkpoint handles that pile extremely well. The other pile is sneaky and correlated. The spec itself was corrupted, or the checker shares the exact blind spot of the system it's checking. And no amount of adding more checkpoints of the same kind will touch that pile at all. Shrinking the first pile is real progress. Pretending it makes the second pile disappear is the mistake. Know which pile you're standing in front of, and you'll know exactly how much to trust the gate.